Good evening, everyone. My name is Deepak. Today I'm going to tell you about Nand to Tetris project. It's an operating system where we're going to talk about. First, what are we going to learn? The idea of this project is to make a software using Boolean logic system. Like we use NAND gate to implement the software. At the end of the project, we'll be able to know how to run a software such as known as Tetris. We'll be learning about in further video. Now, the first task is to create a hack computer. Then create a multiplex in NAND to Tetris software. Now, what is hack computer? The hack computer is made of several components, including RAM, CPU, along with many other chips. This ROM consists of bootloader program and hack machine binary code, while the RAM is where the operating systems and user applications are loaded. The CPU includes an ALU control unit and arithmetic logic unit, which work together in a hack machine. Here, the ROM and the CPU are like virtually connected, and the CPU and RAM are virtually connected for the indirect connection of ROM and RAM. Now, Project Zero. Like here, we are going to know learn how to install an anti-Tetris software. First, open the anti-Tetris organization website and download the anti-Tetris software suite. Now, like you'll be finding a zip file where you have to download it, and you'll be having two folders known as Tools and Project. And in Tools, you'll have all the simulators, and in the project, you have all the projects. And you have the complete projects and software in it, and you have to before running the project, you have to install a Java compiler from Google. Like there are many sources available in it. No, first, like what is a Boolean logic? Like Booleans are basically shown as with 0 and 1. There are three basic gates, and, or, and not. Like AND gates are like this in like we'll be having two inputs and one output, like in general most of the cases. Okay, for the AND gate, if the inputs are either there's 1 0, you'll get an output as 0. In the OR gate, if either of the input is 1, you'll get as output 1. And then in NOT gate, if the input is 0, you'll get an output 1. And if the output is 0, you'll be inserting an input as 1. Like reverse in the NOT gate. And these are some expressions for AND and OR. And it's the same logic you're going to use in AND gate and OR gate. Like basically in AND gate, if either one of the input is 0, you'll get output 0, and if either of the input is 1, you'll get an output 1 in OR gate. Now, first, like what is Boolean expression function? Like in Boolean and expression function, you'll be representing two or more AND gates or OR gates using an AND gate or OR gate. Like a Boolean expression is logical statement using true or false. A Boolean function refers to a function having n number of entities or variables. So it has two n number of possible combinations of the given variable. Such a function would only assume 0 or 1 as their output. Like in this case, x and y, you'll be giving two inputs, and for not and x and z, you'll be giving another input z, and have to do the operation for not x and z, and doing another operation for x and y. And for those both operations, you have to do an operation called OR operation. Then you'll get the output. That is S. There are some laws for Boolean identities: commutative law, associative law, distributive law, and De Morgan's law. Commutative law is like if x and y is equal to y and x or y is equal to y or x. Like basically, it's the mass laws. Like x plus y plus z is equal to z plus y plus x. Basically, it's the same laws we're going to use here. And De Morgan's law is a different law we're going to use. For not x or y, you'll be using for OR gate, it converts to an AND gate in De Morgan's law. And this is the language you are going to use in the hardware uh, anti-Tetris software. It's known as hardware description language. First, get the complete data of what gate you are supposed to know. Then the input and output of the chip are mentioned. A separate section class is written which explains the logic diagram. Here you can see the code what are the inputs and the outputs, and the XOR gate has been basically figured for you. XOR gate can be made use of two NOT gates, two AND gates, and one OR gate. And the NOT gate has input and one input, one output, and the two AND gates has two inputs, two output, and the OR gate has two inputs and one output. All these operations to combine will get an XOR gate. Now, what is an HDL simulation? Where now this is the simulation where we're going to run this all the XOR gates and many other gates. It has three types: in practice simulation, strict case simulation, with or without outcase and compare files. In the interactive simulation, we run the code in HDL code and test all the cases. In the script-based simulation, if we run the HDL code along with another file, which is test-based script, like we'll be running two files same at the same time. That is the code, and that is another test-based code. And in this, we compare output and other data and verify. Now, what is an interactive simulation? First, we have to load the file into the HTML simulator, enter the values for each input. Now, this output consists of two parts. That is the final output and the output of each chip we are going to use. Script-based simulation. In the script-based simulation, we are going to have two codes. One is the logic gate code and one is the test code. We'll be writing the XOR gate code in, using the chip code, and we are going to test it using given inputs. Like we'll be having two inputs like 00, 01, 10, 11. We'll be giving those inputs as test code, and we'll be writing XOR gate using NOT gate, AND gate, or OR gate. And here, like we can see where we are going to get the test code and where we are going to get the HDL code. And here we're going to use the input ports and output pins. Now, what is a multi-bit bus? Buses of bits which are together and can be manipulated together called bus. Each bus can be manipulated to get a desired output. Buses can be divided into called subbuses. Like for example, if A of 0 to 7 is equal to 8 to 15 MSB is equal to LSB. Now project 1. Here in the project 1, we are going to use 15 gates. Like we are going to run these 15 gates in this software. Like normal gates like NOT and or. And there are multi-way variants like multiplexer and demultiplexer. In multiplexer, where we are going to give multiple inputs to get one output. And in demultiplexer, we will give one input and get multiple outputs. Now, like basically for a multiplexer, you'll be having two inputs and one set bit where it may be 0, it may be 1. And for multiplexer, the general code is if set is equal to 0, output is equal to A, else if set is equal to 1, output is equal to B. And here's the code where you can see, and here's the basic multiplexer diagram. And it's in a two-way multiplexer, enable selection on outputting. One of the two possible inputs are digital listen and communication network. Now let me show you the software, like where we will run the XOR gate in the HDML simulation. Now this is the basic HDL software, and here we're going to give the input bits, and here we're going to give the output bits, and here we're going to get the test case code, and here goes the HDL code. Basically, now here I'm going to give an XOR gate code, which has already been saved in the built-in chips, and this is the basic XOR gate code, and he'll be having two inputs and one output. In the XOR gate, let me just one. And if we give one input as 1, you'll get output as 1. And if we give both the inputs as 1, you'll get output as 0. Like this is the code we're gonna use for XOR gate simulation. Okay. Or let me check. Mm. So this is all the basic process of the Nand Tetris software simulation using XOR gate. Okay. Thank you.